Last time we have seen a Schrodinger's time dependent equation. So this I by h cross dou psi by dou t is equal to minus h bar square upon 2m plus a v psi is a time dependent equation. But in physics there are many more problems where energy is independent of time. That is, it is only the function of a position only, and such a type of the problems can be solved by eliminating a time parameter from this equation. Okay, and this can be done by a separation of variable method, and therefore here this psi of xt is a function of psi of x and a phi of t, and therefore here this psi of xt is a function of, so this is the only a function of x, whereas this phi of t is only a function of t. And therefore if we substitute this psi of xt is equal to psi of x and phi of t in Schrodinger's equation, then we have, and therefore first we write Schrodinger's time dependent equation. So this r h cross dou psi by dou t is equal to minus h bar square upon 2m dou t psi by dou x square plus a v psi. So equation 1. So this is a one-dimensional Schrodinger's time independent equation. Now put here a psi is equal to psi phi in above equation, means this can be substituted here, and therefore we have I h cross dou psi phi by a dou t is equal to minus h bar square upon a 2m d2 a psi phi by dou x square plus a v a psi phi. Say equation 2. Here differentiation with respect to t, and there are the two variables, one is the psi and another is the phi, but this psi is the function of x only, whereas this phi is the function of t only, and therefore this psi of x as a function of x can be treated as a constant here, and therefore we come out this one. So this is the I h cross psi dou phi by dou t is equal to, now here differentiation with respect to x, and therefore this phi is the function of x, whereas this psi is function of x and phi is a function of t, and therefore here phi treated as a constant, and therefore this is the minus h bar square upon 2m phi d2 psi by dou x square plus v psi as it is. So there is no problem for that. Now divide throughout this equation by psi phi, and we will see what happens. So divide by a psi phi, here also a divide by psi phi, here also divide by a psi phi. So these will cancel to each other, here psi will cancel and it becomes 1 upon phi. Okay, so this I h cross 1 by phi dou psi by a dou t is equal to minus, here what happens, phi will cancel, minus h bar square upon 2m 1 by psi d2 psi by dou x square plus v. So here psi phi will cancel to each other. Okay, so this is equal to equation say 3. So what is this? So this is LHS and RHS. So this I h cross 1 upon psi dou phi by dou t is only function of t, whereas this equation is, so 1 upon psi dou psi by dou x square is only a function of x. And what about v? Here v, we are assuming that our potential energy is only function of x position, and therefore all these parameters, all this right hand side, this equation is only function of only a function of x, whereas this is the only a function of t, and this is the possible only when the each term of this equation is equal to some constant, and we consider that constant is equal to say e. So this is equal to e, means I h cross 1 by psi dou psi by dou phi by dou t is equal to e, whereas minus 1 of h bar square upon 2m dou psi by this is equal to e. Okay, so this is the possible, so this is the condition for that. Now consider the one term, so this one, and we followed the equation, so that is the minus h bar square upon 2m, okay, 1 upon psi d2 psi by dou x square, so this one plus v is equal to e, so multiply by psi on both sides, so minus h bar square upon 2m, so this d2 psi by dou x square plus v psi is equal to e psi, so transfer e psi on either side, it becomes minus, then it becomes plus, therefore h bar square upon 2m d2 psi by dou x square plus taking common, so that is the e minus v psi is equal to 0. Okay, now see what is, so this equation contains there is no time, and equation 3, 4 say, so this is equation 4. So this h bar square upon 2m due to psi by d square into bracket e minus v psi, whether this equation contains time? No, means it contains only energy and positions, and therefore this equation is called time independent equation. Time independent, this equation does not contain time parameter. In this way we eliminated the time parameter from this Schrodinger's time dependent equation. Means starting with time independent equation, we have derived the conditions, we have derived the equation for the Schrodinger's equation, which is the time independent equation. Okay, so this is for the one dimensional, as the particle is moving only in x positive direction. Now for 2D, the same equation, h bar square upon 2m into bracket d2 psi by dou x square plus d2 psi by dou y square plus e minus v as it is psi is equal to 0. So this is the two dimensional. So this is the x axis, this is the y-axis, so this plane of the board is nothing but your a two-dimensional parameter. This equation may be applicable for a surface, to study the surface areas of the materials and to solve the physical and chemical problems. Now in three-dimensional what happens? So for the three-dimensional, so this h bar square upon 2m, one extra term will come here, so this is the 2 by x square psi by y square, and this is the third term z, okay, plus e minus v as it is, e minus v psi is equal to 0. What is this? This is the del square, okay, and therefore del square psi into this one, and therefore this h bar square upon 2m del square psi plus e minus v psi is equal to 0. So this is your a three-dimensional potential equation. Okay, so this is the one part. So this energy term. Now what happens for this second term? We are going to see. Take LHS of this equation and see what happens. So IH cross this IH cross 1 by 5 double 5 by double t is equal to E, and therefore here we transfer this IH cross in either side, 1 by 5 dou 5 by dou t, transfer this here is equal to 1 upon IH cross E, transfer it, so this is the minus I by h cross E is equal to 1 by phi dou phi by dou t. So transfer this dt on side. So this dou phi by phi is equal to minus I by h cross E dt. See, and by integrating this equation, we get integration is equal to, this is the log phi is equal to minus I by h cross E t. Integration of dt is t, and therefore phi is equal to e raised to minus I by h cross E t. Okay, so this is the phi. Now originally we have seen that the psi of xt is equal to psi of x and phi of t. So this value of the phi of t is this much, and therefore this psi of xt is equal to this psi of x into e raised to minus I by h cross E t. Okay, so this is the wave function from the starting particle, where this psi of x is called eigenfunction. Okay, so this is the Schrodinger's time independent equation, which is the very important equation where the function is only energy is the only function of the position. It not depends on time, and such all problems are solved using this Schrodinger's equation. So there are the two Schrodinger's equations. One is the time dependent and another is the time independent Schrodinger's equation. So these are the basic theory for the quantum mechanics. Once you understand this Schrodinger's equation, you can solve all the problems using these two equations.